So, Passport to Advanced Math, Lesson 11, deals with what we used to call in algebra solving literal equations. Now, the standard they use is Passport to Advanced Math Standard 14, which is use structure to isolate or identify a quantity of interest. So, let's take a look at the first one. In this problem, the setup is a key part. It says the density of an object is found by dividing the mass of an object by its volume. So you have to know density is equal to mass divided by the volume. Which of the following equations gives the mass m in terms of d and v? Well, so what we have to do here is solve this equation for m because it wants the mass in terms of d and v. So we need m equals what? Well, to solve this, all I'm going to do is multiply both sides by v. That cancels those. What I do to one side, I have to do to the other. So right away now, this leaves me with m equals v times d. So m equals d times v, which is letter A. Okay. Now the next one is a big step up. All right. A website uses the formula above to calculate seller's rating, R, based on a number of favorable reviews, F, and unfavorable reviews, N. Which of the following expresses the number of favorable reviews in terms of the other variables? So basically, we're taking this and solving for F. Okay. Now, to do that, I'm going to do the first step here. Anytime I have something like this, what I'm going to do is multiply by the denominator, which would be n plus f, right? And then I'm going to multiply by n plus f. That will eliminate that. So now I have r times n plus f equals f. Now what makes this complicated is this f right here. How do I get that out of there? Well, the first thing I'm going to do is I'm going to go ahead and distribute this r. R times n is rn, plus r times f is rf equals f. Now, what I'm going to do is bring all the f's to one side. So I'm going to subtract rf. Okay, now, if I look at this, I would get r, let's just do this. Let's go f minus rf equals just rn. Now, if you remember factoring out the greatest common factor, both of these can be divided by f. So I'm going to pull that f out and then divide both of these by f. And when I do f divided by f, I get 1. Rf divided by f is r, right, equals rn. Now, f is linked to this quantity by multiplication. So what do I do to undo multiplication? I divide. These cancel out, and I'm left with f equals rn over 1 minus r. Now, also, don't forget another, when I look at that, that's going to be letter B, right? All right. So, the next question is a two-parter, all right? And the first part is actually the easy part. It says, at a large distance r, right, from a radio antenna, the intensity of the radio signal I is related to the power of the signal P by the formula above. Which of the following expresses a square distance from the radio antenna in terms of the intensity of this radio signal and the power of the signal? So what you have to understand here is they want to know which of the following expresses the square of the distance. Well, up here they tell you distance represents r, and r squared tells you we need to get r squared by itself. And it actually tells you in all the answers here. Okay, so how do I do that? Well, the first thing I'm going to do is if I take I equals p over 4 pi r squared, first thing I'm going to do is multiply both sides, right, by my denominator. That'll get rid of all of this, and I'm left with 4 times pi times r squared times I equals p. Now, when I look, I have to get rid of 4 pi and I. Well, all of these are linked to r squared by multiplication. How do I undo multiplication? Divide by 4, divide by pi, divide by I. These all cancel. Then I do the same thing to the other side. So r squared is equal to p over 4 pi I. All right, and that is letter B. Okay, now the next part says, for the same signal emitted by a radio antenna, observer A measures its intensity to be 16 times the intensity measured by observer B. So the intensity of A is equal to 16 times the intensity of B, right? What fraction of the distance of observer B the distance of observer A from the radio antenna is what fraction of the distance of observer B? So basically, I know right away that I have the intensity of A is equal to 16 times the intensity of B. So what I'm going to do is replace this with, right, P over 4 pi r squared equals 16, and that's going to be the distance of A, Then 16 times P over 4 pi r, that's going to represent the distance for B squared. Now when I look at this, this becomes the same as 16 times P over 4 pi r squared, and that's the distance for B. Now, this gets pretty intense to solve. So what I would basically do is, for something like this, I would go ahead, and if I have a fraction equals a fraction, I would just go ahead and cross multiply here. That would give me P times 4 pi r squared, and that's for B, equals 16p times 4 times pi times r squared for A. Now, my goal, right, now is, if I look at this, if I divide by P, I divide by 4, and I divide by pi, I'm going to divide by P, I'm going to divide by 4, and I'm going to divide by pi. P's eliminate, 4's eliminate, pi's eliminate. P's eliminate, 4 eliminate, pi. Now I'm left with r squared for B, so the distance of B, right, equals 16 times the distance of A. Well, my goal is to figure out what fraction, the distance of observer A from the radio antenna is what fraction of the distance. So now what I'm trying to do is figure out the distance of A. So the first thing I'm going to do is take the square root of both sides, and that would give me r distance for B equals 4, right, r, the distance of A. All right. So now when I solve for A, r sub A, I'm going to divide by 4, and r sub A would equal the distance of B divided by 4th, which means the fraction is 1/4, letter A. Okay, that's a tough problem, right? You should know kind of an idea just from mental math what that's probably going to be, but to solve it the long way, that's how you would do it. The last one's another little complicated one, okay? The dynamic pressure Q, right? So that's dynamic pressure equals, can be found by Q generated by fluid moving with velocity V, so V is velocity, can be found using the formula above, where N is the constant density of the fluid. An aeronautical engineer uses the formula to find the dynamic pressure of fluid moving with velocity V and the same fluid moving with velocity 1.5 V. What is the ratio of the dynamic pressure of the faster fluid to the dynamic pressure of the slower fluid? So we're basically looking for the dynamic pressure of the slower S to equal the dynamic pressure of the faster moving fluid, right? Now, you know the velocity of the faster fluid is equal to 1.5 times the velocity of the slower fluid. So right away here, we would say 1/2, right, n v squared is equal to, we're going to say now the faster fluid is 1/2 times n times 1.5 v of the slower, all squared. So right away when I look at this, it ends up being 1/2 n times v squared, and that's the velocity of the slower, equals, when I do this, it's going to give me 1/2 times n times 2.25 v squared. And remember, that's of the slower. So right away when I look at this, 1/2 n v squared slower. So when I break this down and put this in terms of easier to read, I'm going to write this down, and I'm going to go 2.25 times 1/2 times n times the velocity of the slower squared equals, now I'm going to write down this side, 1/2 n times the velocity squared for the slower. If you look, these two things match up, right? These are the same thing. So when it says what is the ratio, right? When I basically look at this, this ends up being 2.25 times QS is equal to right away the dynamic pressure of the faster. So when I look at this, if I divide by QS, I get QF over QS is equal to 2.25 to 1. So you could do one of two things. Your answer would be a gridded response of 2.25 or 9/4. This is a tough problem, but just by plugging everything you know into the problem could help out tremendously.